A bridge.
This bridge is going over one of the most used streets in Stuttgart.
It takes about a half hour for a body shell to travel 94 yards over the bridge to the paint shop. The paint shop's first step is a car wash that removes dirt and grease. Bodies are then blow dried to remove any lingering dust. Once the surface is clinically clean, it heads into a paint bath containing almost 16,000 gallons of paint. The bath holds an anti-corrosion paint called cathodic dip primer. The cathodic dip primer is electrically charged positive. The metal carrier that holds the car carries a negative charge. As the car is submerged, the carrier agitates the car, making sure the positively charged paint is drawn to every part of the negatively charged body. When the car emerges from the bath, the bond of the paint is so strong that excess paint can be washed off with water. Now the car heads into a dryer for 30 minutes to cure the cathodic dipped paint. A single speck of dust can ruin a paint job, which is why technicians dust the body before the primer coat. The interior of the car is primed by human painters. The exterior is where the robots take over. The primer is electrically charged positive. As the robots atomize the paint into the air, the paint is attracted to the car's negatively charged surface. It may look like the color coat, but it's not. The primer can be one of 5 colors: white, light gray, dark gray, yellow, or red. The selected primer color is the closest match to the color coat. With the primer complete, the car heads into a 338-degree Fahrenheit dryer for 30 minutes. Now, it's time for the car to get its color coat.
The most popular colors for a Porsche are black, white, red.
Porsche offers 12 standard colors, plus 9 premium colors. But for a fee, Porsche will custom paint your car any color you want. Because of the number of colors offered by the factory, the color coat is painted by hand. Painters are trained to paint the body from front to back, beginning with the top before moving to the sides. It takes 3 years of training before a painter is allowed to spray the color coat onto the cars. Ventilation systems supply clean air through the painter's masks as they spray the water-based paint. In all, over a gallon of paint is applied depending on the color. With the color coat complete, the 911 heads into a 320-degree Fahrenheit dryer to cure the paint. The final layer is a solvent-based clear coat. The clear coat is painted by robots because the same clear coat is used for every car. The robot is also programmed to open the doors of the car and coat the interior surfaces. The paint shop's final job is putting the Porsche logo on the vehicle's hood. In all, it takes 8 hours for a 911 to enter the paint shop as a steel shell and exit a painted car. Now, preparations are underway to build the vehicle's 6-cylinder heart. From the very beginning, since 1964, the heart of the Porsche 911 has always been a 6-cylinder engine. But not just any 6-cylinder engine. 6-cylinder engines come in 3 major types. Some are straight 6s. The most common 6-cylinder engines are V6s. The Porsche 911 has always used an engine known as a flat 6-cylinder, with 2 rows of 3 cylinders horizontally opposed to each other. Porsche believes there is a key advantage to the flat 6 design when used in its sports cars.
The biggest advantage of using a flat 6-cylinder in the Porsche 911 is its low center of gravity, because it's very small. You can mount it down low in the body.
The lower center of gravity contributes to improved handling.
The lower the center of gravity is, the more stable the car is at high speeds and the cornering.
Those famous flat 6-cylinder engines are made in the factory's engine assembly area.
In Stuttgart, we build in total approximately 500 engines per day.
Every 3 minutes, the plant completes a flat 6 engine. The plant makes more than 20 different versions of its flat 6-cylinder engine, ranging from 255 to 535 horsepower. Each version of the flat 6-cylinder engine has many of its own specific parts. The challenge is getting the right parts to the right place, just in time for the engine's assembly. So Porsche developed an automated logistics system. In the logistics building, a computer illuminates lights near the parts bins, indicating to a worker which parts to pick. Once the part is picked, the worker pulls a string, shutting off the light. Engine parts are loaded onto a cart. The cart is then picked up by Porsche's patented driverless transport system. Carts are programmed to take a specific route to the engine assembly area. The route takes them over a bridge and into an elevator, where they go down 1 floor and deliver the parts to the engine assembly area just in time. The factory has a total of 21 carts. 9 of the carts are dedicated to removing completed engines from the engine assembly area. The carts take the finished engines back up to the logistics area. But how do the carts know where to go and which path to take?
Wir haben im Boden alle 5 Meter entfernt Magnetpillen eingelassen.
Every 5 meters we have magnets embedded in the floor which are covered by concrete. And between one 5-meter distance and the next 5 meters, the cart is programmed to find its way. This, for example, is such a spot.
Each cart travels over 12 miles every day at speeds of over 3 miles per hour. The people on the floor seem to know how to stay out of the cart's way, but just in case, there are safeguards.
Wie wir sehen, passieren tut nichts, obwohl da ein hohes...
As we can see, nothing happens even though it's carrying a heavy load, and these carts move at quite a high speed. But nothing can happen because we have a built-in safety system in there.
For every flat six-cylinder engine made, there are 3 parts deliveries to the assembly floor. The first parts delivery is pushed by hand. It contains both halves of the crankcase, the crankshaft, and pistons. Early in the line, pistons are assembled. Then the first 3 pistons are carefully put into the crankcase. Then, the crankshaft is placed into one of the crankcase halves. That first row of pistons is linked to the crankshaft. Then, a robot installs the second half of the crankcase and bolts it on. Now, the partially assembled engine travels to the main engine assembly line. Meeting that partially assembled engine, a special carrier called a crossmember. The crossmember allows technicians to maneuver the engine for easier assembly.
You can rotate the engine, you can lift and lower the engine, so that the workman always works in an optimal ergonomic position.
2 stations down, a technician puts the crossmember to work, flipping the engine on its side and installing the remaining 3 piston heads. The technician cranks the engine to check the piston linkages with the crankshaft, ensuring the operation is smooth. Next, a cylinder head is placed onto one side of the engine. The cylinder head contains valves that will let air into the cylinders and take exhaust out. Technicians put the crossmember to work again, flipping the engine, so the other cylinder head can be installed. Every 2 minutes and 44 seconds, the engine reaches a new station. Some stations are manned by human beings. Others are handled by robots.
Automation makes sense in those places where many things are repeated. If you screw 20 screws into an oil pan, it's not necessary that one employee screws in 20 screws. A robot can do that. That doesn't achieve any added value. But if you have complex assembly procedures, you need the employee.
About 2/3 of the way through the line, every engine goes through what's known as a cold test. Here, the engine is electrically cranked and turned. Its linkages and systems are checked by computer. After the test, the intake manifold is installed.